Hello friends, welcome to Learner's Planet. Friends, this is our third session for factorization of algebraic expressions. In our previous session, we have learned about the factorization of monomials and when the binomial terms are common between two terms. Okay, now in this session, we'll be taking more problems based on factorization and some different patterns we are going to cover. Just have your paper and pen with you and solve the problems with me. Okay, now let's begin this session. Now we will discuss about factorization by grouping the terms. In such expressions or polynomials, we have been given an expression in which we have to observe that certain pattern is being followed. Okay. Now just see the first question. Here we see the first two terms and the last two terms. In the first two terms, x is common, and in the last two terms, z is common. Okay. Now suppose we take x as common from the first two terms. I can write it like this. So x square by x will be x, and xy by x will be y. Plus, I can take z as common from these two terms, or it will be the HCF of xz and yz. If xz is divided by z, I'm left with x, and yz is divided by z, I'll be left with y. Now, this expression has been converted to the previous pattern which we have discussed in the last session, that one binomial is common between two terms. Now x plus y is a binomial which is there in this term and in this term. Okay, now x plus y can be taken as common, or maybe you can say it will be HCF of both of these terms. Now x plus y, I take it as common. Then at the first step, x plus y divide by x plus y, I'm left with x, and z into x plus y divide by x plus y, I'm left with z. So this is a two-step factorization. Okay, first of all you have to group the terms, then you can write it like this, and you can show the factors. Okay, similarly in this problem, from first two terms, what I can do, I can take b as HCF or as common factor. Then I'm left with a minus y. From these two terms, I can take minus y as common. So I'm left with a. It's minus ay divided by minus y. I will be getting a. Okay. Plus y square divided by minus y. I'll be getting minus of y. Okay. Now we see a minus y over here and over here. So I can take a minus y as HCF, and or I can take it as common. Now I'm left with b minus y. So a minus y and b minus y are the factors of this expression. We have grouped ab minus by and ay plus y square. Isn't it so easy? Just it is a two-step factorization. Okay. Now just see this is this and this. Okay. First of all, we should make the groups. Now from this group, R can be taken at HCF, then Q minus P. From these two terms, we can take S as common. Then it is Q minus P. Now, the binomial Q minus P can be taken as common. Then we are left with R plus S. Okay, it's very easy. Friends, it is not always necessary that whatever the question or the polynomial is given to you is already in the combination of groups. Sometimes you need to change. And there may be various types of groupings. See, in this case, I can make the group of this and this also, and I can make the other groups also. I just elaborated. First of all, let's solve this. Suppose I am making groups like this. From the first two terms, I can take x as common. Then I am left with a square plus b square. From these two, I can take minus y as common. Then minus y a square divided by minus y, I'll be getting a square, and minus yb square minus divided by minus y, I'll be getting plus of b square. Now a square plus b square is common, so we can do it like this. A square plus b square I have taken common, and I'm left with x minus y. Okay, now instead of that, suppose I make a group of x a square minus y a square and xb square minus yb square. Then also I'll be getting the same answer. Let's do it over here. It's x a square minus y a square plus xb square minus yb square. Now from these two I can take a square as common. I'm left with x minus y, and from these two I can take b square as common, and I'm left with x minus y. So it's a square plus b square and x minus y. So in both the cases we are getting the same answer. Okay, so do not worry much about that which pattern has to be followed for grouping the terms. Okay. Friends, I hope you are solving problems with me. Now let's do this problem. I'm just grouping these two and these two. It's as it is. Nothing can be taken out as common. From these two, xy will be HCF of these two terms. So I can take that as common. Now xy divided by xy, I'm left with 1. And x square y divided by xy, it's plus x. Now 1 plus x is a binomial which is common between the two terms. So I can take that as common. Now if 1 plus x is divided by 1 plus x, I'll be getting 1. Plus if xy 1 plus x divided by 1 plus x, I'll be getting xy. In good number of cases, students forget to write this one. If 1 plus x is divided by 1 plus x, they say they are getting nothing. But it's actually 1 because we are making division over here. We are not subtracting them. So if 1 plus x is divided by 1 plus x, it will be 1 only. So you should avoid this error. Okay. So the factors of this polynomial is 1 plus x into 1 plus xy. Okay. Now let's do this question. Here we can make any combination. Suppose I'm making this and this combination. So I just rewrite it. Now you see, between these two terms, nothing can be taken as common, and even between these two, nothing can be taken as common. Okay, so now further we have to regroup them. So suppose I write this bx over here. So it's ax minus bx plus ay minus by. So it's just a hit and trial. Now from these two, I can take x as common. So x a minus b. From these two, I can take y as common. So y a minus b. Now I can take a minus b as common. So it's a minus b, and I'm left with x plus y. Okay, it's very easy. Now this question, first of all, just observe something should be common between the two terms while you are grouping the terms. So let's take this and this and this and this. Okay, so order can be changed also. Now from these two, the HCF will be L and M. So I'm just taking LM as common. Now LM square by LM, from L by L I'll be getting 1, and M square by M I'll be getting M, and LM by LM will be 1. Minus between these two, N square is common. So minus Mn square divided by minus N square, I'll be getting M, and N square is divided by minus N square, I'll be getting minus 1. So now m minus 1 is common, and I'm left with lm minus n square. So it was quite easy. Similarly, see this question. Between these two, p is common, and between these two, nothing is common. So let's see what happens. So from these two, I'm taking p as common. So I'm left with p square q divided by p is pq minus pr square divided by p. I'm left with r square. From these two, nothing is common. So I have to take 1 as common. So if minus pq is divided by minus 1, I'll be left with pq. And if r square is divided by minus 1, I will be left with r square. Now we see pq minus r square is binomial, which is common between these two terms. So that I can take as common. So from this I'm left with p, and from this I'm left with 1. So we got the factors of this expression, isn't it? Now let's see this. Here it is x, here it is x, and between these two y is common. So let's do this. From these two, I'm taking x as common, and I'm left with 2a plus b. And from these two, I'm taking y as common, and I'm left with 2a plus b. So finally 2a plus b is common, and I'm left with x plus y. Okay, very easy. Now in this question, the pattern of writing a polynomial is a bit different from the others. So first of all, let's expand it, then we will refactorize it. Okay, so it's a into a, it's a square, then a into minus 2b, it's minus 2ab. I hope you are clear with multiplication of polynomials. And a into minus c is minus ac, and then plus 2bc. Now we have to regroup the terms. We can observe that from these two terms we can take a as common, and from these two terms we can take 2b as common. Okay, now let's see what happens. So first of all, let's regroup. A square minus ac minus 2ab plus 2bc. Now from these two, I'm taking a as common, or I can say HCF. Now a square by a is a, and ac by a is c. Now from these two, I'm taking minus 2b as common. Now minus 2ab divided by minus 2b, I'll be getting a, and 2bc divided by minus 2b, I'll be getting minus c. So we can see that a minus c, a binomial, is common between the two terms. So a minus c can be taken as common, and I'll be left with a minus 2b. Okay, isn't it so easy? Now let's do the next problem. Now here we see in the first two term xy is common, and in the last two term z is common. So we can group it like this. Now let's take xy as common. Now axy divided by xy, we are left with a, and bcxy divided by xy, we are left with bc. Then I am taking minus z as common. Minus az divided by minus z, I'll be left with a. Minus bcz divided by minus z, I'll be left with positive bc. Now a plus bc is common between the two, so I take it as common. Then it is xy minus z. Quite simple. Now this is an interesting case. Here we can take something common from 16 and 24. Then we can take a minus b as common from this term and this term. Okay, so from 16 and 24, what can be taken out as common? What is the HCF of 16 and 24? Isn't it 8? So let's write first of all 8. Now what is the HCF of a minus b whole cube and a minus b whole square? if you are confused at this stage, you can take a minus b as any other number, maybe x. So it is x cube and it is x square. Now what will be HCF of x cube and x square? It will be x square. And what x square is? It is a minus b whole square. So we can take a minus b whole square as common. Now same procedure, 16 is divided by 8, will be getting 2. And a minus b whole cube divided by a minus b whole square will be getting a minus b. Minus 24 is divided by 8 will be getting 3. And a minus b whole square divided by a minus b whole square we will be getting 1. So finally it's 8 a minus b whole square 2a minus 2b minus 3. Okay, just we have simplified this bracket. So it's 2a minus 2b minus 3. Okay. Now let's discuss this question. Now first of all, let's regroup the terms. I'm regrouping x cube and x square y square and then this and this. Okay. Now let's see what happens. It's x cube minus x square y square minus plus x minus y square. Okay. We have to retain the signs. Now from these two I can take x square as common. X cube by x square I am getting x, and x square y square divided by x square I'll be getting y square. From these two only one can be taken as common, so don't forget to write it over here. It's x minus y square. Now x minus y square is common between the two, so I can take that as common. Now if this term is divided by x minus y square, we will be getting x square, and if this term is divided by x minus y square, we will be getting 1. So we got the factors like this. Okay. Now suppose I regroup 6xy and 9y and then 6n minus 4x. So let's rewrite it. Okay. Now from this two, 6 and 9 I can take 3 as HCF, and xy and y I can take y as HCF. Now 6xy divided by 3y will be 2x. Okay. Minus 9 by 3 is 3 and y by y is 1. Now from these two, variable cannot be taken as common. Only 2 can be taken as common. So it's 6 by 2 is 3 and minus 4x divided by 2 is minus 2x. Now here we see 2x minus 3 and here I see 3 minus 2x. So we can reverse the sign. So it's 3y 2x minus 3. I'm just changing the sign over here. So it's minus 2. If I change the sign over here, the sign of the bracket, that means the terms inside the bracket will also be changed. So it's 2x minus 3. Now 2x minus 3 can be taken as common. Then 3y minus z. Quite easy. Now this question, we already have some brackets over here. So first of all, let's open up all the brackets by multiplying the outside terms to the inside terms. So AB into x square will be getting AB x square, then AB into 1 will be AB, then x into a square. It's just a simple multiplication of algebraic terms, plus xb square. Now we have to go for regrouping. Now we can make the group of abx square and maybe xa square and then ab and xb square. So let's rewrite it. Now what can be taken as common? From x square and x we can take x as common, and from here it is a and it is a square, so further the HCF will be a. So xa can be taken as common. Now abx square, if divided by xa, then we are left with, from a to a we'll be getting 1, then it is b, and x square by x we will be getting x. Okay, plus x by x is 1 and a square by a is a. From these two we can take b as common. So here we are left with a plus b square by b is b, and x is already there. So it's like this. Now this is bx plus a and it is bx plus a. So now bx plus a can be taken out as common from these two terms, and it is xa plus b. Okay, so first of all, what we did, we simplified the bracket, then regrouped the terms according to our conveniency, and it may be a hit and trial also. You can change the grouping also, and finally we got the answer. Okay. Friends, you might be observing that there is no particular pattern or method for regrouping the terms. It's just a hit and trial method. Okay. So now let's see this. Here, suppose I take this and this and this and this. Okay. So it's x square minus 2ab, then minus 2ax plus bx. Now from these two and from this two. Now nothing is common. If nothing is common and from this place x is common, so we cannot take a common factor. So this regrouping will not work. Okay. Now suppose I change it. I write x square and bx together. Then minus 2ax minus 2ab. Now let's see what happens. From these two I can take x as common. So I'm left with x plus b. From these two I can take minus 2a as common, and I'm left with minus 2ax divided by minus 2a. I'll be left living with x, and minus 2ab divided by minus 2a, it will be b. So now I see x plus b is common. Just take it as common and we are left with x minus 2a. Okay, so it's quite simple. I tried this but it didn't work. Then I retried this and it worked. Okay, so it may happen in even your case. So don't worry much about it. Now let's try this sum. Let's group the terms like this. From these two, x square can be taken as common. Now x cube by x square will be getting x, and minus 2x square y by x square we will be getting 2y. Similarly, from this 3 can be taken as common, then y square can be taken as common. Now here we left with x minus 6 divided by 3 is 2, and y cube divided by y square is y. So x minus 2y is common between the two terms. So let's take it as common, and then we are left with x square plus 3y square. So it's very easy. Now let's try this. First of all, we have to open this bracket, or we have to simplify this bracket. So let's do that. abx square plus ay into x, that is axy minus bx minus y. Now we have to go for regrouping of the terms. So let's take this and this together, and this together. So let's rewrite it. abx square minus bx plus axy minus y. Now from these two, b is common and x is common. Now abx square divided by bx, we will be getting ax. Then bx divided by bx, we will be getting 1. From these two, y is common. Then we are left with ax minus 1. So finally it is ax minus 1, bx plus y. Isn't it quite easy? Now let's see this interesting question. Here it is ax plus by whole square plus bx minus ay whole square. So friends, we should use the identity of a plus b whole square and a minus b whole square, or we can say x plus y whole square. That means, first of all, I'm just writing down the identity. Do not get confused between this a and this a. So a plus b whole square is a square plus b square plus 2ab, and a minus b whole square is a square plus b square minus 2ab. Now we will be using these two identities to expand these two expressions. Okay, now first of all, let's do this. Here it is this pattern. So it's a square x square plus b square y square plus 2abxy. Similarly, here it is b square x square plus a square y square minus 2abxy. Now here it is 2abxy positive and here it is negative, so they will get cancelled. Now we are left with these four terms. Now we can regroup. Suppose I regroup this and this and this and this. So let's rewrite it. It's a square x square plus b square x square plus a square y square plus b square y square. Now from these two I can take x square as common, then I'm left with a square plus b square, and from these two I can take y square as common, then we are left with a square plus b square. So finally it is x square plus y square, just a moment, it's x square plus y square into a square plus b square. So in this question we have used two identities, then we regrouped the terms and finally we factorized. Okay, now let's try this question. It's a square x square plus ax square plus 1 into x plus a. First of all, let's simplify the bracket. A square x square plus ax square into x is ax cube, then 1 into x will be x and plus a. Now let's regroup the terms, these two and these two. Okay, from these two we can take a as common and x square can be taken as common. Now a square x square divided by ax square, we are left with a plus a by a is 1 and x cube by x square is x. From here we can take 1 as common because the HCF of x and a will be 1 only. Now a plus x is there, we can take this binomial as common, then ax square plus 1. So these are the factors of this particular algebraic expression. Okay, friends, in this session we have discussed about the factorization after regrouping the terms. Okay, in the next session we'll be taking more such problems and patterns of factorization. Do revise this session and the previous sessions of factorization. Bye bye.